So I have another question up here that has to do with simplify the rational expression. The last one we did, we factor out the top, factor out the bottom, but they didn't have any GCFs. Here I have a guy that we're going to have to worry about GCFs. So we're going to talk about how to do factoring with GCFs. So at the very top, remember, it says simplify the rational expression. For me to simplify, notice that there is no multiplication symbols here. So what I need to do is create multiplication symbols, and the only way to create it is factoring. So we're going to factor out the top and then factor out the bottom. So for us, the top is 5m squared minus 10m. To factor that out, we notice it's two terms, but before we do two terms, we're going to see if there's a GCF. Notice if we go through A through D, we do have the same letter. We do have the same number hidden in fact. So we're going to take out a GCF for the 5 and the m. They don't have matching parentheses, doesn't start with a negative. When you take out a 5m after both of them, then you're going to have a leftover of m minus 2. Now that we have our leftovers, we're going to see if we can break that down any further. When you look at that, you'll say, two terms, can we do difference of squares? No, we cannot do difference of squares because this and this are not perfect squares. So we have this broken down as this. That's multiplication. So we did factor it. Let's break down 25m minus 50 now. Let's see. Even though it's two terms, you're going to see, do we have any GCF? No matching parentheses here, but we have the same number. Letters now doesn't start with a negative, but remember, this is the same thing as 2 times 25. So if I divide each term by 25, my leftovers are going to be m minus 2. So I factor out the top, and I factor out the bottom. Now when I factor out the top and bottom, notice m minus 2, m minus 2, the binomials match exactly. When the binomials match exactly, you can cancel them out. One on top was one on the bottom. So you're left with 5m over 25. Now some people think you're done. And you might say, well, there is nothing that matches. But here's the tricky part with GCFs. If you look down here, it says since most GCFs are one term, you can break them up even further to cancel them out, okay? So you can take this guy, 25, you can break him down as 5 times 5. You can break this guy up, 5m is the same thing as 5 times m. Because this is multiplication, they're factors, you can cancel this out to say our answer is now m over 5. Why can I do this? Because this is leftovers or monomials. Do not try to do it up here. Why? Because there's no monomials here. This is a binomial. I do not want to see 5m, m, 2, 5m. Because these are binomials, you're not allowed to break them up as a tree diagram. But once I got the GCFs by themselves, we're allowed to break them up because these are monomials. This is separate from this because it's multiplication. So be careful when you have GCFs. If the GCFs don't match exactly, you can break them down a little bit further. When you have binomials, you do not break them down. Okay? You have to see if they match exactly. If they do, they cancel out. If they don't, you have to keep the binomials. But monomial GCFs can break down. So this is our final answer.